Hello everyone, we have a problem here in mathematics and it's something from 1215 and 1220 which is intermediate algebra and college algebra. And I'm pretty sure everybody has seen it, that the quadratic formula, which is right here, one of the most famous formulas in mathematics, which is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a, comes from the quadratic function in the form of ax squared plus bx plus c is equal to 0, such that a, b, c, and x all belong to a set of real numbers. So this is done. So note, to complete this, we must follow, or not follow, sorry about that, we must complete the square, which is not that hard, but it can be a little bit complicated. So here we go. So I have ax squared plus bx plus c is equal to 0. The first thing when completing the square, we must ensure that a here is equal to 1. At this point, we're not sure. However, if we divide or factor it out, it will. So what I'm going to do is I'm going to multiply my whole equation as ax squared plus bx plus c is equal to 0. This will become ax squared times, well, we're going to run out of space there, so let's change that. We're going to have ax squared times 1 over a plus bx times 1 over a plus c times 1 over a is equal to 0 times 1 over a. This, we know that this part here, if I can find it, where is it? Here. This part there is 0, so we don't have a problem with that. And we have here cancels with this one. And there's anything else I can cancel, so we have x squared plus b over ax plus c over a is equal to 0. Now we want to create what is known as a perfect square trinomial, which is, that's what we are going to be completing the square does. So I'm going to send this c or over a to the other side, so this becomes, therefore this becomes, so now we have x squared plus b over ax is equal to negative c over a. Now to create my perfect square trinomial, I'm going to create my b over a and use it to create a new c right there. But we must remember that what we do to one side, we must do to the other, as stated by Bashkara II. Ooh, that was a hard one. So this means this, we have x squared plus b over ax plus b over a, and I'm going to put that over 2, and I'm going to square that. Remember, completing the square. And I have equals negative c over a, and what I do to one side must be done on the other side. So squared. Now I'm going to do a little bit of simplification here. So this becomes x squared plus b over ax plus b over 2a squared is equal to negative c over a plus b over 2a squared. Now, the only thing I did was here, I'm going to use this as a different color, b over a over 2 over 1. So I'm dividing a fraction divided by a fraction, and we do use the reciprocal of this. So this becomes 1 over 2, so b times 1 is b, as stated here and stated here, and 2 times a is 2a, like saying here. So just to save space, I will remove this part, and now we're here. I will continue to work on this using this side, and I'm going to keep this, and this becomes now x squared plus b over ax plus b over 2a squared is equal to negative c over a plus b squared over 4a squared. And this is because if I have a function, or not, sorry, an exponent in the form of a over b to the power of m, this is the same thing as a to the m over a to the n. So using this property, I was able to change this from this. So now we're gonna again erase this just in case. We need a little bit more space. And now I have x squared plus b over ax plus b over 2a squared is equal to, now before I continue, I'm still elaborating on the right side of the equation. So notice how we have 4a squared here and a. So to be able to add and subtract them together, I must have the same denominator. So I'm going to multiply by 4a on both sides here. So this becomes negative 4ac plus b squared over 4a squared, which now becomes x squared plus b over ax plus b over 2a squared is equal to b squared minus 4ac over 4a squared. Now, let's go back to our initial equation or problem. And if we pay attention to this little part, we have b squared minus 4ac, which we have here. This, once we complete the square and solve for x, which is what we're going to be doing eventually, this is known as the discriminant, which we'll talk about that. And I can't spell, so discriminant. Where is the going back? Net. Okay? So now that we're here, we're going to get this, and we're going to factor. So this will become x plus b over 2a squared is equal to b squared minus 4ac over 4a squared. Now, what I usually get is, wait, what happened? Where is that b over a? Well, it's still there. It was just hidden. So I'm going to change color now. And this is a side note. So I'm going to put side note. And we have x plus b over 2a times x plus b over 2a. Using FOIL, I'm going to distribute. So I have x squared plus b over 2ax plus b over 2ax plus b over 2a squared. Now x squared, we have 2b over 2ax plus 2b over 2ax plus b squared over 2a. These two cancel out, so this becomes x squared plus b over ax plus b squared over 2a. And don't forget your parentheses, please. So as you can see, b over ax is still there. It was just hidden like over here. So now that we have this, we have x plus b over 2a squared is equal to b squared minus 4ac over 4a squared. Using the square root property, I'm going to get rid of this. So I have x plus b over 2a is equal to plus or minus b squared minus 4ac over the square root of 4a squared. Remember that now using the square root, that square root can be written if I have, this is the same thing as 1 over an. So it has the properties of the exponents, and like demonstrated a minute ago, I can distribute that exponent into both the numerator and denominator. So now I have x plus b over 2a equals to plus or minus. There's nothing I can do to the numerator, so it's just going to stay inside the square root. But now the square root of 4 is 2, and the square root of a squared is just a. So now I'm going to send negative b over 2a minus b over 2a. These two will cancel, leaving me with x is equal to negative b over 2a plus or minus b squared minus 4ac over 2a. Now we're adding and subtracting two fractions, and they already have the same denominator, so I can rewrite this as negative b plus or minus b squared minus 4ac over 2a. So now we have demonstrated that the quadratic formula comes from a quadratic equation in the form of ax squared plus bx plus c is equal to 0.